Okay, hello, welcome back, and we're finally really getting into the really fun stuff. We're going to start building a robot, and so I think I'm going to split this video into two. We're going to have one that explains sort of the robot, and its layout and its new electronics, and then we'll talk about the code in the second video. First thing I want to show you is what do we actually have here. It's a pretty simple machine. Roboticy sells these as a kit, which certainly makes getting all the parts handy. But if you're building something from scratch on your own or modifying a toy, you can set up something like this on your own. We use these Tamiya gearboxes, which are readily available. You need to have some sort of a battery pack. 3-cell works nice. These are small motors. They don't like a whole lot of voltage or current. We use these polypropylene balls as a sort of a tail wheel. And of course you can see here I have a 9-volt, in this case rechargeable battery, that ultimately is going to run the logic when the robot is autonomous. Going to this side, we do have one change here. If you recall, we pretty much left it with the piezo, which you can see I've removed from it for the moment. But right before that we were doing the turn signals, and I had two homemade switches hooked up that were connected to these 10K pull-up resistors. Well, I've removed that homemade system and have put in some of this music wire, pretty stiff wire. This can be a little hard to find sometimes. It's not, the average hardware store probably isn't going to sell it. Maybe the big box, probably a really good hobby store. But again, like I said, we bundle it. And you can see now, instead of having that little homemade thing, what I've got is this wire is connected to this screw, which is hooked to this black wire. Let me zoom in on that so you can see a little bit better. All right. The black wire is connected to the spring steel, and it goes straight to the ground bus. All right. The white wires, for example, this one goes to, I should zoom in, not too far. Let's zoom out a little bit. There we go. Goes to the two 10Ks. So this white wire goes to that 10K pull-up resistor, and this white wire goes to this 10K pull-up resistor. So if this is pushed against here, it grounds out the circuit just like it did with our homemade switch. And if this one hits here, it grounds out the circuit just like it did with our homemade switch. So now we have feelers for our robot so it can help it in navigation. Now let's move into the big change. I put on this thing a motor driver. It's an L293 chip. And let me zoom in a little bit. We'll look at the wiring, but actually before we do that, let's look at the actual chip. Here's a schematic. You can see it has, depending on how these are labeled, usually these are labeled, this one and this one, pin 1 and 9 are labeled enables. So if this is high, if it has voltage, it enables essentially this side of the chip, which is one DC motor. If this is high, it enables this side of the chip, which is one more DC motor. Here we have the voltage into the chip, okay, which is at logic level, so we can supply it with our 5-volt supply. I think there's some flexibility there, but we'll put in a 5-volt supply. And then here is our voltage that runs the motor itself. So this is going to hook up to our 3 AA batteries. The way this works, and these guys are all ground. It has 4 grounds because it needs to be able to handle quite a bit of current. I think these are rated at 1 or 1.2 amps per side. And what you'll notice is the motor hooks up to these outputs. So this would be one motor over here. And then the inputs would be going to the logic. So if, for example, input 1 is high and input 2 is low, that's going to steer the electrical flow so that maybe this one becomes positive and this one becomes negative, and the motor is going to spin either in a clockwise or counterclockwise rotation. If I flip that so that I make this high and this low, then it's going to flip these two as well, and we're going to see the motor spin in the opposite direction. Same thing happens over here. The motor connects to outputs 3 and 4. The logic hooks up to input 3 and 4. If I have one high and one low, it steers the electrical flow in one direction, and if I invert those two, it steers the electrical flow in the other direction. We're going to have it wired pretty much like this. The only thing is that because the little Mini Pro doesn't have a lot of I/O, we're going to have to be kind of cautious with how many pins we use. We're going to tie the enable 1 and the enable 2 directly to the power bus. So it essentially means that both sides of this chip will always be on for as long as power is coming to the board or the chip. So then we only need 2 wires dedicated to running one motor, again a high or a low. By the way, if 2 of these go low, the motor stops. And here the same thing. These 2 pins are going to control this motor. High or low is going to be clockwise or counterclockwise. So going back, let's look at what I've done here. If you look carefully, let's see, maybe we should do this side first. The enable, you can see, is connected to the power bus. The chip itself is powered directly to the power bus with this red wire. The battery, which is currently disconnected, okay, this is my battery coming in, the 3 AA batteries. I have a little sort of homemade switch. To turn it on, I simply move this jumper from here to there, and that enables the power, but I just don't want my batteries to go dead, so it's off right now. And then let's look at this. You can see this would, if you recall, this pin, this resistor hooked to pin 2, 3, 4, and 5. So I have right now on this side pin 4 and 5 connected to these 2 inputs. So if I set one high and the other low, it's going to then steer the charge either positive or negative, and it's going to cause the motor to rotate one way or the other. I have the exact same thing on this side. These 2 yellow wires go to the resistors, hard to see, but they hook in right underneath here, that are hooked to pins 2 and pin 3, and you can see the enable is hooked directly to the positive. The grounds are grounded here, okay, and like I said before, for the moment the battery is in fact disconnected. This jumper, which would hook the 9-volt up, would eventually connect right here. Alright, I don't know if there's anything more I have to show you before we go to code. I will say that I like to keep things neat, and if you're going to do a sumo or something, you don't want your robot's wiring hanging around getting caught in the antennas of other robots. So I use these aren't really doing anything electrically, but I use little staple shaped wires to hold things down so it looks nice and neat. I think that's it for now. So what I'm going to do is we're going to end this video, and I'm going to set you up with some code. See you shortly.